Question 4, we've got a transformation question. So it looks like there's a series of transformations occurring to this function, which you may recognize as an absolute value function now. And so what we're going to do is we're going to start by listing all the transformations that are occurring, and then we're going to code them one at a time with different colors. So let's see what kind of colors I have for highlighters. Well, let's just count how many transformations there are. There's a 1, 2, 3, 4, 5, so I'm going to need 5 colors. Okay. All right. So we'll try these guys. All right. So I'm just going to start by listing transformations. So I've got this negative here. I've got a 2. It's going to perform some function. It's going to got a 3 here. Orange, we'll refer to this -1. And this 4 will be in lavender. I hope that's notably different from pink. And it is. Okay, cool. So I'm going to start with this negative. So, no, I'm going to start with yellow. Okay. So, it may help you to remember that this is like the function y equals a f of b x minus, oh shoot, I forgot which letter we were using. I think h plus k. Okay. And so our a value here is -2. So a is -2. And so that tells us 2 transformations. First, it tells us we have a vertical expansion by a factor of 2. And the negative plays a different role. So it also tells us that we have a reflection over the x-axis. So it's also a reflection across x-axis. That's an X. Can you see that from the video? Yeah, X. Axis. There we go. Okay. Then we'll move on to this B value of 3. So B is 3. So I'm going to code that. That is, now we've got to remember that B always works in the inverse direction, opposite direction. So it's actually a horizontal compression by 1/3. Okay. And then we've got this h value, which is -1. And so that's going to code for a horizontal shift left 1. So I'm just going to write that as a shift to the left by 1. And then we have this k value here, which is 4. And so that's going to be a shift upward by a factor of, sure, you can close it, upward by a factor of 4. And it looks like certain highlighters, my pen bleeds through, so I apologize for that. I'm going to write that again up here. This is a vertical shift upward by 4. Okay, so we got to choose what the order is. And so I think the memory device we used in our class was don't reuse toilet paper, which means we're going to do our dilations first. Dilations, then reflections, then translations. Okay, so we've got dilations. We've got 2 actually, a vertical expansion and a horizontal compression. So could do either one of those first. I'm going to arbitrarily choose the first one we listed to go first. And then we're going to do our reflections. We got a reflection across the x. That's going to be step 3 in green. And then step 4 is going to be both of these translations at once. So I'm going to do both of those at once. 4 and 4. Okay. So step 1 is we're going to vertically expand by a factor of 2. So that means all of our y values are going to get multiplied by 2. So I'm still going to have a value here on the y-axis because the y values are 0, pardon me, x-axis. However, this point here at 0, 3 is going to be multiplied upward to give me 0, 6. Any of the any of the y values in between here, I could also multiply by 2, and if I do, I get a line that looks like this, and a line that looks like so. All right. Then we're going to do the second transformation, which is the horizontal compression by a third, which means all of our x values are going to be multiplied by 1/3, and it's going to get a little scrunched up here like that. Okay. Then, in green, we're going to reflect that across the x-axis. So this is going to be bounced downward like so. And then we shift to left 1 and up 4. All our values get shifted left 1 and up 4. So I'm going to use just orange for that. Oh no, I'll write it in 2 steps. So left 1, everything moves to left 1. So that's this one. And then up 4. So that's going to be in purple, and or lavender, that'll be our last one. So each of these values are going to move up 4. 1, 2, 3, 4. 1, 2, 3, 4. And this one, 1, 2, 3, 4. Okay. Looks like there's a lot of extra juice on this thing, so I'm going to see if I can get rid of some of that before using it. It's a little better. Okay. No, it just likes to give off fluid a lot. All right. And there we go. This is the function y equals -2 f of 3x plus 1 plus 4. Okay. So moving on to question 5. We've got this transformation here. We had original function, which is like a radical, and we have all these transformations on that radical shape. Okay. So again, we're going to just go one by one. So we've got an a value of 1/2, which means we have a vertical compression by 1/2. Our b value is -1/3. Because this kind of looks like if we had y equals a root, that's our function, -1/3. B, no, just a general b. There we go. And then we'd have an x minus h, and then plus k. So each of these values in here are going to correspond to one of our letters. And so our b of -3 is going to tell us 2 things. It's going to be a horizontal expansion, because it's always 1 over b, expansion by, instead of 1 over 3, by 3. And also there's a reflection, and that reflection is in the x direction. It's going to be reflection across the x, the y-axis. Okay, then next we have an h value of, looks like we'd have a -3 here, and if you take -3, we get x plus 3 is the way that simplifies. So that means there is a horizontal translation, and that is 3 units to the left. And lastly, we have this k value, which is -9, which means we have a vertical translation 9 units down. Okay. Moving on, let's go to question 6. Okay, we have this shape that has been translated. It looks like, which one are we starting with? The graph g of x is a solid line. Okay, so this is g of x here. And it looks like there's a new function, a transformation of this graph. So we're going to try to determine all the ways in which this graph has been changed from this graph. Okay, so I think we can probably start with our a value. So to do that, I'm going to look at how much this changes from starting at 0 going up to 6. It's 6 units high, and this value is, or pardon me, this function is only 2 units high. So it looks like there was a vertical compression by a third, because 6 went to 2. This is going to give us an a value of a third. Okay, now I'm going to look at the horizontal compression here. So it looks like there's also a horizontal compression. It's also 6 units long in this direction, but our new function is only 3 units wide. So because 6 compressed to 3, that looks like we have a horizontal compression, but only by a half this time. Okay, and that's going to tell us our b value is going to be, oh, remember we got to flip or take the reciprocal of a b value. So the b value rather is the reciprocal of the compression or expansion. So it's actually going to be 2. Okay, and now might be a good time to take a second to imagine what this graph will look like just by doing those compressions. All the y values would get multiplied by a third. So this guy would be brought down to here. And all the x values are compressed by a half. So this one's going to come down here. And so that's this graph. Just so we're clear, I'm graphing the line y equals 1/3 g of 2x. So that's an intermediate transformation, but it's going to help us to determine the other types of transformations that occurred. It looks like, what else is happening here? It looks like there's a reflection across the x-axis. Notice, by the way, we're following our memory device. We're dealing with dilations first, then reflections, and lastly we're going to think about translations. If we start thinking about translations first, it's going to actually get us a little bit confused. All right, so we can imagine this looks like it was reflected across the y-axis. So reflection across the y-axis. So it's actually going to take our b value, and instead of 2, it's actually going to be -2. Okay, that's supposed to be an arrow. It is not perfect. All right. Then we can imagine that our new function is over here, and that's not pretty, but it was meant to represent, you can imagine y equals 1/3 of g of -2x. Now, we weren't asked to draw these or label what partially transformed functions they would be, but I'm just doing this to help us trace our steps so we can see now it's maybe pretty obvious that actually to get to this final form, we have a shift upwards or translation upwards or vertical translation 2 units up. So that's going to give us a k value of +2. And so then our final function is going to look like y equals 1/3 g of, oops, I don't need that guy there. Second, I'm just dealing with the whiteout. There we go. 1/3 of g of negative 2x plus 2. That's our k value there. Okay, that's our final value. Final transformed function. And there would be a little multiplication in there, but the whiteout's a little white, so I might add that a little later. All right. So, okay, now we're asked to sketch this radical graph. Okay, that's question 7. So I think what a useful thing will be for me to do is, okay, we've got these 3. We're also asked to use highlighters, so I'm going to highlight each of these transformations, kind of like we did before, and I think it was the green and the lavender that were a little seepy, so I'm going to just use the orange and the pink. And those are going to represent each of our transformations. So I can see that we have this a value equal to 2. That's what we're going to code in yellow. And so that means that'll be a vertical expansion by 2. Looks like we have this h value, which is negative 3. And that means we are having a horizontal translation to the left 3. And lastly, we have this k value of negative 2. Which means we have a vertical translation down 2. Okay, but we don't have a function to start with, so we need to start by thinking we need a base function. Our base function, y equals root x. And it's okay if we don't know specifically what this thing looks like. We can try to generate a table of values to create it. So I can imagine, well, what's going to happen if x is 0? Well, I'm going to square root 0 and get y is 0. So I'm going to have a point at 0, 0. What about if x is 1? Well, I can square root 1, and square root of 1 is also 1. So I can have the point at 1, 1. And now I'm square rooting, so I probably want to choose numbers for x that I can square root. So I'm actually going to choose 4. I'm going to skip some. Square root of 4 is 2. So when x is 4, y is 2. By now, maybe this graph is starting to come back to you a little bit. Okay, so there's our function. And that's the function y equals root x. That's our base function, what we call that. Okay, now for the first, I'm going to use my yellow. Oh yeah, by the way, just so we're clear, we're going to use this DRT memory device. Don't reuse toilet paper, which means we're going to do our dilation first. We don't have any reflections in this case, but we do have these 2 translations. So I'm going to arbitrarily choose that one to do second and this one to do third. All right, so we're going to multiply all the y values by 2, and so we get a value here, here, and 0. It doesn't really change. So our first step is going to look something like that. And we're going to shift all of our y values down 3. So this is going to be 1, 2, 3. That's going to go down 1, 2, 3. And this y value is down 1, 2, 3. And there we go. And, oh, stupid. No, that was wrong. This is actually a horizontal shift 3 to the left. Pardon me. Okay, there we go. So I should actually have shifted that to the left 3. So it's over here, 1, 2, 3. This guy's going to go 1, 2, 3 here. And this one is going to move 1, 2, 3 here. And we're going to start getting a curve that looks something like that. And then pink, now we shift down 2. You guys move down 2, down 2, down 2. Oh, it's going to hit right there. And then this pink guy is our final curve.